We now move on to our next session titled Systems Engineering for Big Stadium Events. Um, this session will explore systems design and engineering for large shows in stadia. This session will be delivered by GERT Sana, Senior Consultant Education and Application Support, DNB Audiotechnik. GERT has worked for almost 3 decades in the live sound industry as a system tech and front of house engineer for shows ranging from corporate events, Broadway shows, large-scale stadium tours, and major UK festivals. GERT is now the Senior Consultant Education and Application Support for DNB Audiotechnik. Let's put our hands together for GERT Sana, everyone.
Wonderful. So, give us a second with the screen and then we can start. Hello, good afternoon. My name is Gert. So, we're going to talk a little bit about Stadia. So when Leslie von Ansata asked me to do this presentation, I didn't realize I only had 45 minutes. And the reality is, to discuss a stadium design, you kind of need a little bit more than that, than 45 minutes. So what I'm going to do now is I'm going to touch a couple of points, and I hope I'll be done in about 30 minutes or a little bit less than that, and then we have the rest as a conversation starter. Interesting noise here for this being the lighting hall. So, sound system designs for large stadia and large events. So, quick picture about me. I used to be, or I'm still very into much photography. I take panorama photographs, and many years ago I made a photo where there is 2 of me, split personalities. And what that actually means is that's the system guy, and that's the guy who mixes the show. And in large events, that should never be the same person. But we can discuss this any further. So, in 1987 was my very first gig for money. First time I got paid. I was extremely clueless, very clueless, but luckily so was the band. It was the local cover band that played like rock songs and stuff. But I sort of got a little bit of an idea of what I wanted to do. For those who don't know, I have a degree in printing. So got nothing to do with all of this when we had lawyers and bankers. So I'm a printer, so get yourself in there. So my first international tour was in 1990. It was a musical called Oklahoma, and it was we toured through Germany, and we had an orchestra and everything, and I was the radio guy. And in those days it was like big receivers, like 1 channel receiver was like a 2U box, and we had 8 radio mics. We were a massively modern show then. And my job was to swap the radio mics, the packs between the actors when they walked on and off the stage, because we never had enough microphones to do all of them. So that was a good start, and then I then moved up the ladder in the theater world, and I did up to mixing in theater and system design. And theater was great, and I can only encourage everybody to have a look at theater work, because it learns, or it teaches you how to learn. Because in theater you have to learn the show, you have to know the cues, you have to know when they say something, and you develop yourself a system on how to learn a show. And it's extremely helpful even with a rock band if you understand how to remember things that are coming up in a gig. So that was really useful. And from 1999 to 2012 I was a freelance engineer, and I used to live in the UK for that already. And I was working with companies like SSE and Wigwam, and I did many festivals and stuff like that. That's where I honed my system engineering skills, and far more importantly, I had the choice of, or not the choice, but I had the opportunity to work on different systems or different manufacturers, which is a good insight. And then from 2005 to 2012, in that side, I was also known as the guy who mixes Deep Purple. I was here in Bangalore with them once. It was an exciting gig. I remember staying in a hotel where Winston Churchill has an unpaid bill at the bar. I thought it was quite funny. It was a picture of that. And since 2012, I'm actually in regular employment. My dad always said I should get a real job, so I did. And yeah, here I am. So now, um, let's have a quick look at Stadia and what the problems are in Stadia. And feel free to add any to the list. Now, when you see these great videos of bands playing in big stadiums and stuff, you always think, I wonder how it sounds in there. All right? And because on TV it always sounds quite a lot nicer. And how can we make it sound nice in a stadium as well? So you have to remember before you even start working that a stadium is not made for concerts. Stadia are made for sports, and the reason they sound like they do sound is because people in sports like it when the crowd cheers, that it reverbs and that there's echoes and stuff, so it multiplies the audience experience for a sports event. For us in audio, not so much. It's not so great. So we have a few challenges. So one of them is the RT60 time. For those of you who don't know what the RT60 time is, it's the time in seconds it takes for the level of, for any given sound level to decrease by 60 dB. Sometimes it's not measurable because it's too quiet. Then you can do a trick. If you want to measure it, you can measure RT30, which is 30 dB loss, and then, or if the background noise is really high, like here, you measure 30, and then you double it up, and then you come to RT60 as well. So, what does that mean for the concert sound system? How can we work with it? Because we can't work against it. I'm pretty sure you've heard people say, we need to turn the PA up, we need to get over the reverb. Trust me, that does not work. So you need to work with it, not against it. Right? So, and the next thing, a typical stadium, when you play it long ways, as they say, even a short ways, a big stadium has quite long distances to cover. Much more than a speaker system is capable of doing, even ours. So we need to work on how do we get level to all the seats, and how much do we get to them. So what does that mean for coverage? You know, how even can we get it? We will have a look at a few drawings I have here. And what about low frequencies? I always say sound engineers have an unhealthy relationship to channel 1. Most people are obsessed with a bass drum, and therefore with the bass of a system. However, if you have to shoot 140 meters and you got 60,000 people, just putting all the subwoofers in one big pile in front of the stage is going to be maybe okay in the last row, but in the first row it's very unpleasant. So we need to think about people, where are they and what are they receiving, okay? So that's why I wrote where to put the subs and how. Another thing, a big stadium typically provides a really steep profile. So especially in the outfill scenarios, and I'm going to show you some screenshots in a minute, you have to go possibly up a lot, and you have to open up the angles quite a lot. And in general, for stadium shows, you need a lot of PA. You can't do it with a little bit. Not possible. And then the usual stuff, rigging, as we just heard in the previous session, can be very difficult. Because sometimes there is no roof, then you have to bring one. And then we're in the whole mobile scenario. And what does that do to the pitch? Sometimes the players are not keen. I can tell you, in cricket stadia, they're not happy about you putting a stage on their pitch. So access can be difficult sometimes. I remember once we were loading into Munich Olympic Stadium, and whilst the truck was full with motors and chain hoists, it fitted easily through the door, but once it was empty, it didn't fit anymore, so we lost the whole truck because he got stuck in the door and the roof was broken. So things you have to remember is you can't really get in there easily. Trim height. What's a good trim height? I've recently been to shows as a show support where the PA was flown really, really high. Is that a good idea? Or is it maybe not a good idea? Let's have a look into that. Let's discuss that a little bit. And last but not least, in order to also be respectful, we all share the same physics. Nobody has any better ones. right? We all have to deal with the same crap, so to speak. Right. So let's have a look at some average RT60 times. That was the thing I spoke on before, which is the reverb in a room, and how do we get there? And what makes it difficult? So if we look at a radio studio, obviously very dry, very short reverb, there's not much going on, right? Let's have a look at some other things. A rock venue, 1.2 seconds as the longest one. It's pretty okay, not really difficult. An opera house, 1 second to 1.6, depending. I've seen some which are a little bit longer in reverb, but in opera houses we already get into the situation where people design the room reverb to play naturally, so it's not made for amplified music. So it's a different approach. Concert hall, that would be probably a typical arena as well. A cathedral can be up to 4 seconds. And anybody here who's ever put up speakers in a cathedral knows it's tedious. I was on tour with a gospel band once and we played churches only. I was ready to commit suicide after 1 month. And this room, I have no idea what the reverb time is. So now I'm going to show you an RT60 curve, which I generated in ease. Ease 5, by the way, get it? It's cool. And this is 7.2 seconds in the mid-band. That's really a lot. What does that mean, 7.2 seconds in the mid-band? If I say hello, it takes 7.2 seconds to get out of there, out of the room, before I can clearly say the next hello. Now, that might be okay if you listen to Kenny Rogers with his slow songs, but heavy metal is probably not going to work. So, where does that reverb come from? Reverb comes from reflection. I'm going to show you a little Ulysses analysis I did years ago, and it basically shows you how first order up to 7th order, so 7 reflections, how much one speaker can fill a small room up like that. And then imagine there's hundreds of thousands and hundreds of speakers in a stadium, and you get an idea of where the reverb goes. So where it comes from. So that's reflection number 1. Yeah. So you can see the sound bounces on against the ceiling, against the floor, and back wall, and comes back, and it bounces around. Now, depending on the room volume and the surface of the surface areas around it, this can get quite tricky. Second order, that's basically reflections of the reflections on top of it. And now we move this all the way. I just don't comment. We get a bit quicker, but you get the gist, right? So that's where the reverb comes from. It comes from the reflections in your room. That's where you get it from. So what does that mean for us listening? Have a look at speech intelligibility. That's an easy one, because I'm one of the guys who believes if the vocals sound good, the rest will sound good too. It's the most important audio piece. So what do we have here? We have an area that's called direct sound, and we have, this is the reverb level we refer to as diffuse sound. That's the stuff that just stays in the room. And unlike the direct sound, it's everywhere. It basically fills up the room. And you notice when you're in a really reverberant space and you hit the snare drum, it eventually is everywhere. And if the source signal doesn't stop, i.e. because it's a song or so, eventually you get to this level here. And the good thing we want to hear is the direct sound. We want to listen to direct sound. That's the sound that comes directly from the source, from the speaker. Now, we get to a point that's commonly known as the critical distance. And the critical distance is the point where the reverberant or the diffuse sound is the same volume as the direct sound. That's not necessarily the area where it sounds bad, because you would be surprised how close that is. On a big arena show, sometimes even 30 meters. So 3.14 times of the critical distance is what we refer to the limiting distance. Limiting distance is no longer acceptable audio quality, right? So we are looking at this whole area. Now, if somebody says, turn it up, we need to get over the reverb. What's going to happen is if you turn this sound system up, the reverb level will increase and the direct sound will increase, but at equal levels. In other words, you have the same problem, just louder, right? So that's not good. So what do we need to do? For concert audio, we need to increase the critical distance. We need to try to move this further back. Right? So the only way we can do that is if we create less reverb. So the most important thing in a stadium sound system is create less reflections. And what we can do is we can use high directivity sound systems. So directivity is everything. So a system that's consistent in its dispersion, ideally slightly more narrow. So wider dispersion systems are usually create a lot more reverb. Then of course we need to carefully focus the system. That means we need to make sure we don't point it anywhere where there is no audio needed. Glass walls, point away from them. Use technology to get away from them. Accurate display angles and processing. So depending on what system you use, you might want to open up display angles between so you miss a wall, or you use a technology in our world, it's called array processing, where you can make sure you can shape that a little bit better. A big one is subwoofer systems. Use or create cardioid subwoofer systems. Do anything you can, end fire, whatever you can come up with to make sure that your subwoofers are directional. Because the lower the frequency, typically, the more 360 the speaker goes. And the subwoofer typically is a sphere, goes all the way around. And if you can make them not go to the wall behind you, behind the stadia, the better it is. But nevertheless, sometimes stadia do this. So this would be a sound system designed specifically for sports. So as a football match down here, as a screen on one end and on the other, and they play adverts and hey, score a goal and whatnot. So this is a system that has a very specific job. The speakers are actually here, pointing that way. You'll see some in a minute. And you can see we try to stay off the pitch. Why? Well, as a football team or whatever, cricket team or anybody's playing there, those guys need to be able to communicate, they need to be able to speak. So they are not there to be entertained, they're often millionaires, they get entertainment afterwards. So we try to make sure we keep off the pitch. Now that's not a scenario we are talking about, we're talking about a system that could look something like that. And so we put a stage in this stadium. This is just a little SketchUp printout. And we have a couple of components here. I'll just quickly show them to you. We have a subarray here. Anybody who uses DNB knows we have a subarray calculation tool, but others do as well, so it's not unique to us. Then we have what we would call the main PA system. And you can already see it's not very high in my design here, right? We have what we call the outfill. And I hate it when people call it side fill, because a side fill is monitors, it goes on stage. All right, that's an outfill. We also have here a so-called 270 system. Some artists are so good that people buy tickets to see them from behind. So we call it 270 system, right? That's quite common. And then here you can see a couple of the other systems that are in this design, which are the regular sports system. And here we have some delay towers. We have in this design, we have 4. So let me quickly show you what I would like it to look like in the end. like that. So you can see already it's a little bit louder and it's quite even. And here's the stage, and it's quiet behind the stage. So this is a 4 kilohertz plot. At lower frequencies it would look a little bit different, but it's easier to show where I'm getting at, right? So that's a really big stadium, 65,000 seater. And in the back there's video screens and stuff, so we try to get as little reflections from the back as possible, okay? So how does this system come together? What are the individual components? And where do they point at to get to a picture like that? Because that's the important bit, right? So let's have a look. So this is just the main system. And here's the first error most people do, is they go too far. This is the main PA, probably the one the front of house engineer listens to. And we're not focusing all the way to the back, up the bleacher. With this one, we try to stay in the ball. We cover the pitch. It's very unusual. Most people don't quite think that way. But the pitch is always good because it's often not reflective, and especially when it's sold well, it doesn't create any real big troubles. So then we have the outfill system, and that's a slightly different profile, as you can see here. So I try to stay within the ball, and you can see I've quite accurately focused it here in the back. So there used to be a school of thought saying, hey, what about overshoot? Do you do overshoot? And I go, absolutely, I do, if I can. Right? And the thing with the overshoot is, should the overshoot create a reflection, I need to make a decision on where I want to send this reflection. So if this is an open stadium, I can happily overshoot, as you can see here, only by a half a degree or so, because if there is a reflection, a glass wall in the back, the reflection would go up at the same angle as the impact, and it would go up and above the stadium, out of the way. And it'll be quite a long distance, so it would have lost a lot of SPL over the distance. All right? So this is quite neat. So that's what an outfill system does. And that's a 270 system. So you can see already it moves slightly around, and it has a different profile again. All right. Another school of thought when you do overshoot or undershoot, and doing sound design is always a creation of compromise. So if you make it worse for more people, don't do it. So I wouldn't. So let's say if I do an overshoot to gain 50 seats at the expense of 10,000 seats, I won't do it. Huh? It's a logical calculation, but think about impact, and then. So here we have the delay system, and here you can see something where you would say, "Oh wow, he's overshooting a lot." Not quite. Things you need to consider when you use tools like array calc is, this is the profile on axis, on the 0 axis of the speaker. And if I point here, in the back, you can see that's this one, but it has to cover to the left as well, where it goes up a little bit. So sometimes I rotate it in the design process, get the up angle, and then I rotate it back to where I need it. So neat little trick to do that. And here we have a ring delay system, concert system. And the ring delay, in our world, we do something really neat with it in the venues where we have installations. So in this venue, there'll be a fixed installation of speakers, and the ring delay speakers, they're all rotatable. So you can rotate that array. So typically, as you've seen before in the sports venue, it just points, let's say, straight out, this one. And now I can rotate it 45 degrees, so it points this direction, which is in line with the stage. So I can utilize it as a delay. There's a caveat to that. And the caveat is that the profile will change. So what you need some form of steering possibility without changing the mechanical setting of the array. In our world, that's array processing. We know there's FIR settings. EAW guys have something for that. So if you have the electronic means to change the dispersion of the speaker system, then you can use that. So this would be the arena without the ring delay, without the installed system. That's what the guys would bring in. And in this particular stadium, there's no way you can actually get equipment up here or there to rig it. Well, if you did, it will take you days and weeks. So it's not feasible. So having the rotatable arrays is a really, really neat idea. And then you get to this. So that's the full system now. And that's all the components together. So each component has their individual job and their individual coverage area. And yeah, just believe me, the more narrow the box, the better. So in our case, these are all 8 versions, so 80 degrees boxes. Because the overlap areas here, who has heard the term STI before? Anyone? STI, Speech Transmission Index. It's a measure of quality for speech. How well can I understand a spoken word? It's not a quality measure for audio. A good STI doesn't have to sound nice. You know, like those evac systems you have, or those, they don't sound nice, but you can understand them. But STI is very much dependent on modulation between frequencies. And the modulation increases if you have comb filtering. You have more modulation. And that means if the overlapping areas are bigger, you have more modulation and you have a decreasing STI. So if speech intelligibility is a discussion point, you need to do that. So what about subwoofers? Shall we have a quick look? So this is that subarray in there. And as I said, cardioid is your friend. So you can see already it's pretty loud here. And by the way, who knows why a subarray in itself, or a row of subwoofers in the front of the stage, is potentially better than a left and right scenario? Do you know? Well, there's various reasons for that. First of all, when you stack them all up left and right, you get a massive power alley. You can already see here a little bit of it, but it would be huge in the middle. So the sound would be, the low end sound would be very uneven in a stadium. But on top of it, if you were to make a left stack here, I don't know, 9 or 10 or 12 subs, and you put them all in a big pile, you create a massive point source speaker. And a point source speaker would lose 6 decibels of level with every doubling of the distance. All right? So that means it would lose level quite drastically. If you build a subarray and you stay within the meters, within the range of where the cabinets couple at their frequencies, you create a line array. It just happens to lie on its side. Okay? And when you do it with that, if it's long enough, and in Stadia it usually is, because it's quite big, you end up having, you go further with your sub. Because you then end up in line array criteria world, and then you lose 3 dB per doubling of the distance. It doesn't change the fact that if I want to get the low end loud enough here, I could do a few things. I could turn these up. That would be very unpleasant for those guys. To the point of unhealthy, I would say sometimes, depending on the band and stuff. Who thinks delays is a good idea? They're not. They're not a good idea at all. Especially not if they're not cardioid. Because then what you have is you have, if this is the delay tower here, if they fire backwards, they cause a cancellation here. So you might pick up a little bit more bass there, but you lose it where you really need it. So the only time I would ever use subwoofers on delays would be if they are fully cardioid and if they're flown. They need to be up in the air, out of the way. Otherwise, I wouldn't go there. So what we do on this system is we fly some between the main and the outfill. And even though this area, this load area has now become bigger, it hasn't become louder, right? So that's the idea. So we have more bass coverage now. And the good thing is with those flown subwoofers, if you rotate them out slightly, you don't have to make your subarray in the middle very wide. So you can, by applying more delay on the outside, you can get wider. But that obviously there's always a cost. You press one button and you pay for it somewhere else. And if you do that, you end up not being able to go all the way to the last row. So try to keep the subarray down the front and make it as big as possible. So sometimes people say, what about if we have a poser stage like this in the middle? We can't put subwoofers there. Well, that's unfortunate. That's what I wrote in one of the first slides. We all share the same physics. You have to find a way to put them there. And usually that means speak to the set designer and see if you can put them under it. If it's open, if it's just cloth, then it's not a problem. You can put them there. But it needs to be a continuous line. And another little thing with subarrays always start in the middle and they work their way out. Subarrays are always mono, always. And yeah, and the low frequencies are your most expensive ones, right? So I'm gonna show you a little bit of the array calc for this. Let me see if that's, I hope it doesn't crash now, that's always great advertising. So, so here's array calc. I have this file somewhere. I think it's this one. No, it's not. Oh well. Maybe it is. I don't know. No, I don't think it is. Give us a second. So any questions so far? I'd love to have some. Yes, please. Huh? Hang on, let me come down so everybody can hear you.
So when you talked about that arraying as a subs is better than keeping them as point source, is it just true for a cardioid sub or is it okay for an omni sub also?
It's also better for a normal subwoofer, of course, because it's not only about making it quiet in the back, it's also about having less level loss. And when you build a subarray, you practically build a line array. That's the main reason why we sell line array speakers, is because if you're within the line array criteria with a certain frequency range, you lose less level over distance. Most people think it's some sort of magic, but it's actually not. So the line array effect on any line array is frequency dependent, right? So imagine if you stand in front of a system, and the system is here, and there's maybe 6 boxes. If I stand right in front of it, I'll probably only hear 1 or 2 tweeters, but I'll probably hear all the low-end drivers. And as I go further away, I hear more and more HF drivers as I go further away. And that's how you compensate for the 6 dB level loss, because the level loss is actually the same. The only thing is you're listening to more speakers. So it's about 1.4 times as you double the distance. So that means you lose 6 dB, but you pick up 3 because you're listening to more sources. And if you do that, the perceived effect, it's not the real effect, the perceived effect is that you only lose 3 dB per doubling of the distance. Now, in order for a subwoofer to become a line array, it needs to be really long, right? Well, if you think about it, the wavelength for 100 Hertz is 3.4 meters. So that's the minimum length it needs to have to do 100 Hertz. That also means for 50 Hertz, you already need 6.8. right? So, and so forth. So as if you have a really long subarray, 20 meters, if you have that many, and you walk backwards, as you lose level, you gain more from the speakers, and they have directivity because they are coupling as sources. That's why they have to be mono. As soon as you do that stereo, the whole thing will fall apart. Yeah, it has to be mono. So I always say to people when they ask me, oh, my subwoofers need to be stereo, I just say yes and don't do it. That's usually my approach, and nobody's ever noticed. And so, does that explain it a bit? So, but of course, the cardioid also helps when I know that artists sometimes get a bit shirty when they see a lot of subwoofers in front of them, and they are really loud on stage. They might get the impression that you want to wind them up. So, here's our system now, and I can show you. So here we have the individual sources with the stadium. It's actually not the latest version. I have got a later one. I opened that one up. Hang on, give me a second. I've got this on my desktop. Where is it? There. So any further questions in the meantime? Somebody over there? Oh, one mic would be enough.
Hi. So
Hi.
Hi. So with most modern pop acts, having almost always having a ramp, and
Yeah.
then with the whole, as you spoke, the subs need to be in one line. So you're most essentially being underneath that ramp,
Yeah.
and then your money channel, having cardio at subs, but on the same hand, your money channel is being blasted by a lot of subs,
but-
because they're almost always on the ramp. That's how most of these pop act shows are designed. So what's your take on what poison you'll choose?
Well, I mean, at the end of the day, if you, I don't know how wide these are, sometimes they're 4 or 5 meters wide, aren't they? That's a substantial gap in a subarray.
Yeah.
However, if the left and right is still long enough, you get a bit more of that. But the reality is, you break a subarray apart, it's no longer a proper subarray. And I don't think there is a solution to that other than start discussing this early with your with your stage people and say, guys, can you make it so I can put them under there? And even if you don't have cardioid, I mean, a vocal mic should not be directly in that area. And if you build a left and right stack, the power alley in the middle is much louder than what you get if you have an evenly distributed subarray. Because I show you. This is a good subject. So, for argument's sake, let's just go and have a look at sources. And I'm going to look at this subarray here now. Where do I have it? That's up here somewhere. There you go. That's us. So if I change this subarray now. Ooh, slow, eh? Is it already calculating? And I change it, oh man, here we go. So I change it to 2 sources. Okay. And apply, and then I make these sources, let's say, 30 meters apart. Oh. And then I don't need to apply any delay, so why does it not calculate? I should be able to see this now.
The mapping legend seems to
Huh?
The mapping legend.
Oh, I'm in the wrong. No, I'm not. It should show. Oh, it's not a subarray track. That's why. Let me just quickly open a new file and I'll show you what I mean by that. It's quite easy. It's a very good question because it comes up in the workshops a lot. And so if I just do a big venue here, let's say. But you're right, these poser stages and 360 stages are also a scenario that happens quite often. We can talk about that in a minute. So if I now add subarray. And I'll just do 2 sources. There you go. And now they're on top of each other, and you can see they really distribute quite evenly, really like a microphone would pick up maybe. What subs are these? Oh, these are V subs, that's okay. So now I spread them apart. So let's say we make them 10 meters apart. Apply layout, and then you can see this. And that's what's commonly known as the power alley in the middle. And so just because you don't put subwoofers there doesn't mean the bass is not loud there, right?
So what would be your choice in this situation? Would you like blast your main artist with a lot of subs, or divide it in 2 lines?
Well, let's put it that way. I would try to see with how much I could get away with. I mean, first of all, the vocal channel should have no business with the
right,
subwoofers.
but then the monitor engineer has a complete different reference as to what the artist is experienced in his position on the ramp. So you're essentially putting him on a spot wherein he does not have any of the subs because the stage is clean, but the artist on the ramp has a lot of subs because he's in front of the subarray.
Yeah, but he's also in front of the PA. And I know what you mean. I've been to a situation in Beijing once for a K-pop concert, and it was quite funny because it was quite a few years ago. We were tuning 40 Js per side, so it's 20 main and 20 outfills, and we were just tuning them. And they had 2 poser ramps, one in front of each PA, right in front of it. And this guy was actually trying to get a monitor loud enough. This monitor engineer, and I go, mate, just put it on the truck. They're not going to hear it. Well, then it's, if form wins over function, then we're not really having an argument here. Because if the artist wants to be there, he has to live with the noise. Otherwise, or his audience can't hear him. It's one of the 2 choices he has. And the tricky bit is indeed to have a constructive discussion with the guys about it. And my experience is that the subwoofers in the middle are less of a problem than left and right stops, because they make it even. So if the artist walks out there, some of them actually like it. We had Liam Gallagher complain about SL subs because he doesn't hear them on stage. So that's funny. It's very rare, so we take this with a bit of pride. But yeah, so that's the subwoofer discussion. On top of it, I would like to add that low frequency content in a large reverberant space is always good for masking a lot of things that I consider more important to the music program. Yeah. Oh, we're done already? Oh, really? That was quick. See, I told you, and we haven't even started on center stages and center subs. And shame the Meyer Sound guys are no longer here, because they used to do this TM array for Metallica a few years ago with their subwoofers in the middle. I can tell you it works with cardioid subs too. We tried that. It works really well, so we copied that. So, yeah. If we have to finish now, then I'll finish, I guess. Hang on, I've got one more slide. It says thank you on there. Hang on, where is it? Here. So no more questions. By the way, I'm here for the entire trade show. I'm on the Ansata booth. Come and see me if you have any more need to discuss these things. I like beer, so bring some. All right, thank you.